Cool. Okay, so, yep. Hi guys, I'm Bruno, and this is Robert, and we're from Launchpad. So we're going to be doing a developer's guide to Docker. Hopefully this thing works. So hopefully you all have the slides up and Docker installed. If not, you can just kind of watch us go through it. So we want to start with a brief overview of what containers are, like the concept of containerization, and kind of motivate why someone should use it, or where someone might want to use it. And then after that, we will do the workshop portion, which is going to be the longer portion of it. Okay, so why? Why do we need to use containers? Why is it useful? Let's imagine you're building a typical web application, right? Let's say you're using a language like Python for your web server, and you're running a, I don't know, PostgreSQL database. The languages here don't really matter, but this is a typical backend setup, a server and a database. And think about what's the first thing someone is going to do when they pull your repository with all this stuff in it, and they want to run your app. Like, this is a contributor who's working on a project with you. Well, the first thing they're probably going to do is they're going to say, oh God, I have to install Python. What version of Python do I need? Oh, it's 3.5, and they don't support 3.6 for these libraries, so it can't be 3.6. So I need to go and install Python. Oh wait, it conflicts with all the other Python installations I'm running. That's terrible. Okay, so now you've installed Python after a few hours, or maybe a few minutes. Okay, now you need to go and install the dependencies, right? Now you've got a bunch of Python packages that you need to install, and maybe their versions conflict with pre-existing versions of Python packages you've installed. So what you end up with is, and then you have to do the same thing for the database, right? So setting this up for every developer who's working on the project with you can be a nightmare. And synchronizing it between people with different setups on different operating systems can also be a nightmare. There are situations where, and this has happened to me a few times, where packages don't work the same way, or just don't even exist on some operating systems where they do on others. And so this whole problem of making this uniform running environment for your application where it just works no matter where you run it is a very important problem, not just for development as I've outlined, but for production too, right? You don't want to go and configure every production server for running your app, because that's just going to take a really long time to do. So this is where containers come in.
So yeah, as Bruno mentioned, this sort of problem carries forward to anything that you host online as like a service. For example, let's say I have a startup called Robflix, and I'm serving a website to Bruno over here. Now, given that there's only one Bruno, this is perfectly fine. I've got one website. Oops. I'm just gonna use this. I've got one website. It connects to a bunch of small services. Like, let's say I have a user service, and then somewhere to put all my videos, and then something else for managing payments. So this is fine if there's just one Bruno, and I don't have to worry about that many people. But what if you're dealing with millions of Brunos, like all over the world? This one service isn't going to be able to handle so many Brunos. So you want to spin up another instance, or another instance of your website to serve the other half of the Brunos who's on the other side of the planet. Now, with this extra service, you're going to need to spin up all the smaller auxiliary services that you need as well. And once you are dealing on a global scale, this is a huge problem. Like, you could be spinning up thousands of computers every single day and installing your service on them and running it. And making sure that your configuration reflects perfectly across all these devices quickly and efficiently is a huge problem. Now, this is just spinning up. Every day, as half the Brunos go to bed in Canada, all the Brunos in Australia are still watching, but you don't need this extra service, right? So you need to scale down and scale up as your user base sort of comes online and offline. and in order to save money, because these hosts you have, or these machines that you host your service on, they cost a pretty hefty amount of money once you reach this kind of scale. So being able to quickly turn things on and off and configure your application across a wide range of hardware is a pretty important problem to deal with. So the concept of containers comes from what happens if you can encapsulate everything that your app needs within a box. And this box could contain all your dependencies and everything your program needs to run. It can have your code in it, any binaries that you need to build, any libraries. And no matter where you put this box, it's got everything it needs to run. So all you need to do is drop this box on a new computer, and you're good to go. So that's where containers come from. They encapsulate your application and all the dependencies you need to keep it running. Any questions so far? Does this all make sense?
One thing that's really nice about containers, going back to like way before where this isn't going to work, I'm just gonna to way before when we were talking about installing dependencies and stuff. How many of you guys have ever installed, like a typical example, a JavaScript dependency, like a node module, and had it say, warning, this has critical vulnerabilities, don't use this package, like upgrade to a newer version or whatever. Has that ever happened to you guys? If you've written JavaScript, it's probably happened because JavaScript is malware. But that's another nice thing about containers is it actually isolates the stuff running inside the container from the host system. So here's an example, right? We have a regular Linux operating system here that contains a file system and some running processes and a network and blah, blah, blah. And we have our container processes running here. Now, it's easy to think of a container as this, as Robert described, as like this box with everything you need in it. But in reality, it's actually, it's pretty light. It's basically just a set of processes like this that have a restricted view of your file system and your network and other processes are going on in the operating system. It's just a restricted set of processes. And the reason that's nice is because when you install these garbage node modules, they're not going to infect your whole system because they're running in these container processes that have an isolated view of only part of the file system. They can only see certain things. They can't talk with other processes on your host. They can't, a lot of what they can see is very restricted and you can control it. So that's something really nice about containers as well. But this is a very trivial example. This is just where you have 3 processes running in your container. Maybe those are your app processes, and they only rely on some small part of the file system. So that's all they need to see. So here's another view that you can take of containers, where we have, on the left here, we have the almost like a view of the operating system from where the user is running containers versus the view of the operating system when the user is running VMs. And the reason we have this slide is to differentiate between containers and VMs, because often people will kind of describe a container as like a lightweight VM. And it's important that you know the differences between them. So with containers, usually you just have, say, some hardware. This is, if we're just looking at your own laptop, say, this is going to be your hardware. Then you're going to have Mac OS or Linux or whatever running here. And then you're going to have this Docker daemon that kind of provides things that each of your containers need in order to run. But at the end of the day, all these are they're just isolated processes, and they're still running on your host operating system the same way all the other processes in the operating system do. Whereas if you try to deploy your apps as in VMs, well, you need this hypervisor that kind of abstracts away the hardware from the VMs. And each of these VMs hosts the app, But VMs aren't light and they're not they're not easy to bring up and bring down and reconfigure, and you can't take one and then just move it somewhere else. I mean, sometimes you can if you're using good VM stuff, but there's a lot going on now because your app is actually talking to virtualized stuff on top of virtualized stuff on top of virtualized stuff. Whereas with the container, you're just running your app as a normal process on the system. So that's why people will often call containerized stuff containers like lightweight VMs. So don't worry if you don't understand all of this. It's kind of complicated, but that's like a high-level overview. Okay, so there are two core building blocks that we'll walk you guys through when you're using Docker, and when you're using a lot of containerization systems in general, but we're kind of focusing on Docker here. The first one is images, and all the image is it's an image of the container. So it describes what the container is going to be able to see when it's running, what stuff inside your container will see when it's running. And you can kind of layer these images to build your final image. So here, for example, we have the Ubuntu image, and this has the top level directories that you'd usually find in a Linux distribution like Ubuntu. At the end of the day, a distribution like Ubuntu or Fedora, I don't even know if that's not a distribution, or like Linux Alpine or whatever, Debian. It's just a set of standard utilities that exist as the base installation of the operating system, right? So at the end of the day, it's a bunch of stuff in a bunch of files. And this is what this image is. It's just a bunch of stuff. It's just a description of what content goes in what files on the system. Okay, cool. So we need some standard Ubuntu utilities. And we also need Python for our app. So we're going to put the Python image on top of that, which just adds more stuff into more files on the system. So now we have our Ubuntu utilities, and on top of that we have the binaries that are required to run Python. And then on top of that we're going to make another layer, which is our app, which is just the files that are required to run our app. And then at the end of the day we have a big image that is made out of all these layers that is a description of the system that we can use to actually run the containers. So when you create a container from an image like this, you're going to get a process or set of processes that has a limited view of, that is able to view some content based on what's in the image, and also has a limited view of other things on the file system, like other processes, like the actual host file system, so it can't go look at your, like, I don't know, your other files living anywhere else in the operating system. And the network as well, so like if you're running something on your host operating system and you're running something in the container can't say, hey, other process, let me like make web requests to stuff in the host. It can't do that. So this is the main idea there. So with Docker, the way it works is you usually have this Docker daemon that runs as just a regular process on your system. And like if you guys are familiar with daemons, it's basically just a process that runs in the background. If you open up, like if you're on Mac and you open up your activity monitor, you'll see a bunch of processes and you'll see lots of things called like something D, system D, and stuff like that. Those are all the daemons that run in the background and do work for other processes. And the Docker daemon is one of them. And so what happens is you have your command line client. These are just regular commands that you type into your terminal. And that sends instructions to this Docker daemon, and the Docker daemon processes these orders that you're giving it, and it uses them to pull images, like I spoke about here. This is so annoying. That like these images, for example, Ubuntu or Redis whatever. It takes those from a registry, which is basically just files with descriptions of images on them. Or I guess this often exists on the web. So like somewhere in the cloud, there's this big open registry of open source Docker containers that you can pull in. It pulls them in locally and stores these images on your computer, and then it uses them to create containers. And then you run your containers, and that's the way it works. Okay, so we want to take you through two things, networking and volumes. Wow, this is really laggy. So the reason we want to show you networking and volumes is because these are the two things you'll usually configure for your containers. So with networking, you want to describe, for example, what view your container gets of the host operating system or the outside world, and what view the host operating system gets of your container. And so I haven't really included it in this image, but as described before, this container can't go reach out and make calls to other stuff going on on the host operating system, and actually for good reason. Here's a really powerful example of why this is a bad thing. You really don't want your container to be able to talk to the Docker daemon. Communication needs to go that way because the daemon controls the container. But if the Docker container can send stuff to the daemon, well then, if someone is able to compromise your Docker container, they can send commands to the Docker daemon and start new containers, and they basically just took over your system. Like, they now just hijacked your system, and they can run whatever containers they want on your system. And so that's really why, that's a perfect example of like why it's important that these containers are isolated. This can happen on a normal web service, and it often does if you guys have heard of like buffer overflow attacks, but that's a good example of why you don't want this. And so when you create a container, or you run a container, I mean, often you'll say like, this container expose port 3000 of this container to port 80 on the host machine, so that any traffic coming in from the internet to port 80, what did I say? Map 3000 to 80. Whatever comes in from the internet to port 80 is going to go through to your container, but anything else is just going to get ignored. And then volumes are a similar concept. You're saying, hey, this Docker container is allowed to look at these files on the host file system, but nothing else. That's a basic concept.
I'm just going to reiterate a little bit over these two. I guess the key thing to take away from all this is the key concept behind containers is you want to isolate your application from the rest of the system. So this doesn't just include the dependencies that we talked about earlier, but also anything you can access on the host. Another example of why accessing the Docker daemon from a container is bad is the Docker daemon, in order to do all this fancy process restriction stuff, it runs as a root user, which means it has full control over everything on your computer. That includes accessing literally everything. So they can read all your files, all your keys, whatever. So yeah, there's other sorts of stuff that you don't want it to access as well, but that's the gist of it. Yeah, so going back to that startup service, the Robflix or whatever, Netflix, the real Netflix, has a huge number of subscribers and a huge number of users. In order to service all these users consistently and without any sort of downtime, they have to do some pretty crazy infrastructure stuff. So they've got regional deployments. These are completely isolated from one another, 7 of them. And they launch over 3 million containers every single week. So it's basically part of the normal process of shutting down services as certain regions go to sleep or whatever, and then spinning them out in the morning. So this way they can scale their service to match exactly the demand and save money on that regard. So imagine having to configure all these machines, like spinning up 10,000 different machines every day just to deal with scaling your service. Like, it's impossible to do this in an effective manner and without running into all sorts of problems. let's say if Amazon suddenly changes the operating system of something, or something changes on their end, and now everything, like your application doesn't work. You can avoid all those problems by isolating everything your service needs within containers. And there are tools out there available that Bruno will talk about in a bit, tools that help orchestrate these services, like help determine when this container is dealing with too much load, spin up 10 more of them, and so on and so forth.
So here's another example. At Demonware, what they did, what I was working on there is, so have you guys heard of Kubernetes? So Kubernetes is like, it's basically an API around the Docker daemon. You can almost think about that, but it's a lot more distributed. So if you think about like Amazon EC2 allows you to spin up a bunch of virtual servers in the cloud, right? Kubernetes is basically like that, except it allows you to spin up a bunch of containers in the cloud. That's how you can think of it. And so at Demonware, we made tools that we used for load testing our services. So for example, like the Call of Duty Black Ops 4, our services needed to be able to withstand all the traffic for that game. And so we were looking at like millions of users, concurrent users, and at peak game time, maybe like 2,000 to 4,000 logons per second. So we need to be able to generate, to test our services to make sure that they're ready to handle all this load. You need to be able to generate a ton of load, and you need a ton of containers to do that. And so we wrote load test tools that you could just communicate through the Kubernetes API to say, hey, spin up, I don't know, 500 instances of my user simulation containers, point them to our backend services, and go crazy. And then that's like a perfect example of where you'd want to scale these containers up and down and be able to deploy them anywhere you want really quickly, and save money while you're doing it. Do you guys have questions so far?
Yeah, a lot of companies do use this, like not just the companies we mentioned, but a lot of, especially any company that provides an online service, many of them will have some components that feature Docker, simply because it's so versatile and so easy to use it to set up services. Well, not just for development, but also for production environments as well. But yeah, thank you all for coming. I hope that was informative. Our website's there, Instagram as well. Follow us if you want to hear about future events. And we'll probably stick around to pack up and answer any remaining questions that you guys might have.